My name's Stuart. I'm the Offshore Renewables Strategy Manager here at the Energy Technologies Institute. Wave energy is the extraction of electrical energy from wave motion. We look at the different elements of wave energy, we look at the abundance of wave energy, and we look at the possible routes to market for wave energy converters. Wave energy around the UK is a huge resource for us, and it's capable of supplying 10 to 50 terawatt hours of the UK's 350 terawatt hour electrical demand. In our studies, we've found that wave energy is unlikely to meet the cost of energy targets that are contained within the ETI UKERC Marine Energy Roadmap. This calls for a cost of energy of between 10 to 20 pence per kilowatt hour by 2020, and wave energy is unlikely to meet that cost target. This failure to get down to a reasonable target is because of the highly energetic environment that wave energy has to deal with. If we look at the amount of energy in waves and the way that we extract it, the machinery has to be highly over-designed, and that adds cost. In the wave industry, everything has been created from scratch, and that's caused huge costs, huge time for development, and a very unclear future in terms of the form of the wave converter, and then its implementation in arrays. Therefore, we think that there is a real need to go back to the science base and to look at the level of innovation that we can achieve in wave energy, and really to think again. These very complicated wave energy converters need to be much more simple. They need to be much more commercially aware of the targets that they need to aim at. From our wave energy converter project, we have learned that although innovation can reduce costs, in conjunction with array and system engineering and in conjunction with volume manufacture, we can reduce the costs much more. Volume manufacturing will be able to reduce the capital cost of the machine by around about 16 to 20%, whereas we needed maybe 50 or 60%. Well, wave energy is far too abundant for us to ignore. That's the first thing. And if we look at the UK overall energy mix, there should be something in there for wave energy. But right now, I can't see it without going back to the science base and understanding what sort of level of innovation that we need to bring that to fruition. One of the important things that it's worthwhile thinking about at the same time is that although wave energy is abundant in the UK, it's far more abundant in the southern hemisphere, and so there is plenty of potential for UK export jobs, and that's certainly something that we need to think about in terms of the future of wave energy.